Let's play with particle systems in Maya for a bit. Here's a scene I created earlier with just some stairs and a bowl up there. And we're going to use this to throw some particles at. So first we're going to create a particle system. This is done from the Dynamics menu. And we're going to go to Particles, Create Emitter. And we can look at the options. First, reset all the settings to the default. Name it Spewer, because it's going to spew something out. We're going to switch the emitter type to directional. Omni just spits it out in all directions, and volume particles are created from a volume. We're choosing directional. We're going to set the rate, the amount of particles per second, to 25, so there's not too many. And we're going to leave all the others at default. So we're going to create this particle system. And it's created right there in the middle, as you can see. And it's actually on the grid. That's why my grid lives in this scene. A particle system always gets created at the origin of the scene. Let's play this one. And if you look closely, you see particles coming out. We'll make the scene a bit longer, say 300 frames, so we can play it a bit more. And you see it's shooting out grey particles straight into the stairs. So let's move this one up to a more interesting position. Let's put it there, up a bit more. And we want it to throw particles at the bowl. It's still shooting out in that direction, so we have to reverse the direction. So we're going to look at my channel box and look for the direction. It's shooting them out in direction X is 1. Let's make this -1, so it's shooting out the other direction. Before I play it, I always go back to frame 0 to restart the simulation and then play it the other way, and it's shooting out particles in a straight line, which is kind of boring. So we want to have them spread out a bit, not just one line of particles. So let's set a spread, and let's set the spread to like 0.5, see what happens. It's shooting out in all directions almost, about a 90 degrees angle. That's a bit much, so let's set that back to 0.1. There we've got a nice stream of particles. They are really hard to see, so let's stop the animation here. In my particle emitter, there are no settings for the particles themselves, except for how they are created. There's a difference between the particle system and the actual particles. These are the particles. If you look at the outliner, you see that there's a emitter and a particle system. Most of the properties of the particles are set in the particles object, or particles node. For instance, you can set how they are rendered. The particle type by default is points. You can set this to something else, like multi-point, multi-streak, numeric, blah blah blah. Let's do spheres, so they all turn into little spheres. Those are actually rather big spheres. That's the default setting. We cannot change the size of the spheres in the channel box. We have to go to the attribute editor, go to the particle shape, look for the display render attributes. It's particle render type set to spheres. If you hit current render types after add attributes 4, you will get the radius, and let's set it to 0.1 for instance. So we get a little bit smaller balls. Okay, let's see what that does so we can see them more clearly. It's shooting out particles, and it's shooting them out with a certain spread in one direction. Something is obviously lacking, and that is it's not falling down. There's no gravity. So we're going to select the particle system, which we can also do in our outliner. It is selected. And we're going to add gravity. There's a whole dynamics shelf as well, so we're going to switch to the dynamics shelf. And here's a G with the points, with the arrows pointing down. That's the gravity node. So let's hit that one. It will create a gravity field. And by default, that's set to magnitude 9.8, which is the value of the gravity on Earth. So, ooh, they're falling down quite fast. We want them to end up in the bowl. So that's not really happening. There's a couple of ways to fix it. We can lower the amount of gravity, or we can just make the particles be emitted faster. So we'll set the speed of the particles, for instance, to 10. And we can also set a randomness on the speed, so that they don't all start off with the exact same speed, giving more variation to the particle system. That's a bit too much. It's overshooting the mark. Let's go to a speed of 5. There we go. It's hitting the ball, but it's hitting the ball, sort of. It's going through the ball. That's not very exciting. In order for the particles to stay in the ball, we need to set up a collision between the ball and the particle system. So we're going to select the particle system and shift select the ball. In the dynamics shelf, there's a make collide icon. You select the particle object and then select the geometry for it to collide with. This will create a geoconnector. And if we look in the properties of the geoconnector, there's a tessellation factor, which means how much the geometry is subdivided to calculate the collisions. There's a resilience, which is basically bounciness. There's some friction, and there's also an offset between the center of the particle and the size of the hit. We actually have to increase that because we made the particles have a radius of 0.1. We're also going to have the offset be 0.1. There we go. And let's see what happens. Ooh, they're shooting out of the ball in all directions. So the resilience or bounciness is way too high. So let's set that, let's lower that to, for instance, 0.5. See what happens. Yeah, they're still jumping out a bit, so let's lower it even more, or give it a little friction so the speed of the particles is lowered as they hit the ball. Friction of 1 is a lot, I think. Yeah, that's a bit much. They're really staying in the bottom of the ball, so put it on like 0.5. So we've got that happening. We've got these thingies fall into the ball nicely. Let's have some fun with the ball. Let's take the ball and at frame, for instance, 48, so after 2 seconds, we're going to set a keyframe on the rotation, Shift E. And then at frame 96, we'll rotate it along Z, see, by minus 90 degrees. That's a bit much, so let's actually do minus 60 should be enough. And again, set a key right there. Look at the graph editor to see what we've actually done. I switched to the graph editor view, and you see that it's now going in a straight line, the animation. I'm just going to flatten the tangent so we have a nice ease in and ease out. Go back to this view with the outliner because we like that. So now the ball is actually rotating while the particles are falling in it. which means it's going to dump all the particles. They're actually sticking in it a bit too much, so going back to that Geoconnector, I'm going to set the friction a bit lower. So I do want them to fall out of the bowl. There you go. And you see they fall out of the bowl straight through the stairs. We don't want that. We're going to select the particle system, select the stairs, and again add collision. Another Geoconnector is created, and let's see what happens. It's still shooting out the particles, and yes, they're bouncing off of the stairs. They're bouncing quite high, so let's change the settings for the Geoconnector a bit. Let's give it a little bit less resilience, a little bit less bounciness, and also some friction. And again, the same offset of 0.1, because that's the radius of the spheres I show my particle system as. So they're nicely bouncing up the stairs. So we might be quite happy with this. Show this to the director we're working for, and the director will say, no, I actually want those particles to jump down the stairs. So they have to hit the stairs and then jump down. And then you explain that it is physically impossible, that they're shooting this way, so if they bounce, they're going to continue that way. They're not suddenly going to reverse direction. But the story calls for these particles to end up on the other side and fall down the stairs. So we have to think of a trick. We have to push the particles towards the other side of the scene. Now there's a whole bunch of forces up here you can add to use to push the particles to the other side of the scene. We're going to use a radial field pushing the particles away from a certain point. I'm going to double click on it, make sure that we reset the settings, and we're going to call it push away. So it gets created at the origin. We're going to put it up to the top of the stairs because we want it to push down the particles and see what happens. And it's not doing anything. That is because when I created it, I did not have my particle system selected. Luckily, there is an option, and it's right here, that says affect selected objects. Select objects to be affected, then select field. So we're going to do that. The objects to be selected, which is the particle system, then control select the push away radial field we made, and we're going to apply the force. So now this force should be pushing those particles away, and yes, it is. It's pushing them away rather forcefully. So let's look at the settings for the push away. The magnitude is set to 5, which is a lot. So let's set it back to 1, see how that works. Better, but it's still a lot. Actually, we had it hitting the ball nicely. To make sure that the radial field is not pushing the particles out of the ball, we needed to only work up until the ball itself. So we need to figure out what the distance is between the radial field and the ball. So for that we can create a measure tool. We're going to switch to the front view in this case. We see the scene, and we can create measure tools, distance tool. Click on the emitter, and then so about where the ball is, so that's about 4.28 something. Let's switch back to perspective view. Yes, so a radius of 4 would be good. Let's select the field, set the maximum distance to 4, use max distance is on. Let's see what that actually does. A maximum distance of 4. So it's not affecting the particles until they go out of the bowl, and then it starts pushing the particles away a bit. They are jumping down the stairs, sort of. We can increase the magnitude now to say 5, because it's no longer influencing anything outside of that 4 units radius. So they're falling from the thing, and then yes, they are actually bouncing down the stairs instead of up the stairs. So our director will be very happy. And that's it.